Hi, I'm Ana Lara Begurrutia, and the name of my project is Improving the Ultra-Low Sulfur Diesel Quality Using Biodiesel. This year, I'll be presenting this topic in the poster presentation modality, so I will be explaining each one of the parts of the poster. Some studies have predicted that the world will remain dependent on liquid fuels until the 2050s. Electric and hybrid cars and alternative fuel vehicles will play an important role in the years to come, but they will not be able to satisfy all needs of the sector. From oil, liquid fuels such as gasoline and diesel are obtained for passenger and cargo transport vehicles. The growing affectations on the climate and ecosystems produced by the emission of greenhouse gases into the atmosphere are widely known, so a consensus has been achieved to protect the environment through the consumption of energy generated from renewable sources and the production of fossil fuels with a lower content of polluting compounds. The ultra-low sulfur diesel is an ecological quality fuel suitable for reducing environmental pollution and is used in the European Union, North America, and Asia since some years ago. Nowadays, the consumption of ULSD has not been generalized in Mexico and other developing countries due to technical limitation of their hydrodesulfuration units. Although the ULSD obtained from the HDS units accomplishes the specifications for sulfur, kinematic viscosity, and specific gravity, in some cases, the electrical conductivity specification is not accomplished according to the Mexico official standard, norm 016 CRED 2016, and the international norm ASTM D975. This problem makes it impossible to commercialize ULSD for failing to comply with this specification. Therefore, this work was focused on proposing alternative solutions to overcome this problem, mixing biodiesel with ULSD in order to enhance the electrical conductivity of this fuel. The methodology of this project consisted of the following steps. First, it was made a deep hydrodesulfuration of middle distillates at mild pressure conditions in a pilot plant in order to produce ULSD with a sulfur content of less than 15 weight ppm. Once the ULSD was obtained, 5 blends with ULSD and biodiesel were prepared in concentrations of 1, 3, 6, 9, and 12 volume% of biodiesel. Once the blends were prepared, some of their properties were determined, such as sulfur content, kinematic viscosity, specific gravity, and electrical conductivity. So, the results of the characterization of the blends were: for sulfurs, the concentration in ULSD didn't show a trend when biodiesel was added, with a minimum value of 4.8 weight ppm in the F12 blend and a maximum value of 5.4 weight ppm in the F1 and F6 blends. And as we can see, the sulfur content of ULSD increased slightly when it was added. The ULSD and all the blends with biodiesel met the established specification value of 15 weight ppm maximum. Now, kinematic viscosity decreased when ULSD was added. However, the value of this property showed an increasing trend with a higher concentration of biodiesel, having minimum and maximum values of 2.267 square millimeters per second in blend F1 and 2.762 square millimeters per second in blend F12. So the values obtained from both ULSD and its blends with biodiesel complied with the established interval. The specific gravity of the ULSD increased when biodiesel was added and showed an upward trend with a higher concentration of biodiesel, obtaining a minimum value of 0.8222 for blend F1 and a maximum value of 0.8321 for blend F12. And last but not least, the electrical conductivity for pure ULSAD was 0.5 picosieverts per meter, which is very low to meet the specification. The results of the blends with biodiesel showed that electrical conductivity increases significantly as the concentration of biodiesel increases, with a minimum value of 27 picosieverts per meter for blend F1 and a maximum value of 710 picosieverts per meter for blend F12, complying with the specification of NOM 016 CRE 2016. Therefore, it is concluded that it is feasible to produce diesel with less than 15 weight ppm of total sulfur by hydrotreating a mixture of middle distillates at mild pressure conditions. That biodiesel was selected as an additive to enhance the properties of ULSAD, specifically electrical conductivity. All properties accomplished the corresponding specification values of the Mexican official standard NOM 016 CRE 2016. And the blends of ULSAD with biodiesel showed consistent and reliable results since they were prepared following approved experimental procedure and characterized by standardized analytical methods. Thanks for watching. If you have any question, please let me know.